This video is going to focus on how to use density in stoichiometry. Density is a conversion that allows us to get to volume for solids and liquids. So molarity does it for solutions, density does it for solids and liquids. Density does not do it for gases because gases don't have a specific volume because it's temperature and pressure dependent. So we'll come back to that at a later time to talk about it. This video will specifically focus on how to use density when I'm dealing with a solid or a liquid. So density is actually a conversion factor if you think about it. Density, so let's imagine I had something that was 12.1 for its density. That will always be how many grams it has per 1 milliliter. So this is a ratio relationship that allows you to convert from gram to mil. So this can be used within stoichiometric problems if I'm trying to get to volume at some point during the problem-solving kind of situation. So here's an example problem. One of the difficulties with density is that it gives you two different numbers within the problem. And since I always tell you to start with the number given, this can be challenging because two numbers are given. So instead of just starting with a number given, what I would say is always start with a measured number. If I go into lab, things that I can measure are grams, volumes, and then I can't really measure this, but we can pretend like it's a measured number. You could sometimes start with mole if it's given to you. We don't want to start with our conversion factors. So don't start with a molarity, don't start with a density, don't start with a molar mass. Okay? So in this problem then, the measured number that's given to you is 43.8 grams of lithium. Okay? The other thing you can look at is to see that I am trying to solve for milliliters of mercury. So if I started with the density of mercury, I couldn't get myself anywhere from there. So you always want to start with the compound that you're not being asked to solve for. So I'll set this up the same way I always do. Gram on bottom, mole on top, because I want to go to mole because that is how stoichiometry works. Okay. Whenever there's gram to mole, that is called molar mass, which is a number I will pull from my periodic table, which is 6.94 grams per 1 mole. That's the molar mass. Now I wanted to do that first step because now I can do stoichiometry. So this is our stoich step. This is what allows me to, this is the key that unlocks the door that allows me to convert from one substance to a new substance. I'm trying to convert to mercury, which is this one. So I'm going to balance this guy. It looks like I just need that and that. So for every 1 mercury, I have 2 lithiums. Now where I'm headed for this problem, where I want to end up is milliliters of mercury. Where I'm at right now is moles of mercury. There is no conversion from moles to milliliters when I'm not dealing with a solution. So if there was a solution, I can go from moles to liters using molarity. But without a solution, essentially I need to go to gram so I can use this. So mole to gram is no problem. That's a gimme because that's molar mass. Gram to mole to gram, easiest conversion we can get. Just got to pull the number from the table. Okay. And then that next step, which I ran out of room for, would be taking that gram and converting to mil using the density. So the density is 13.5 grams in every 1 mil. And that would then get me to my answer for milliliters of mercury, because that's what the density was. So in my calculator then, I would type in 43.8 divided by 6.94 divided by 2 times 200.59 divided by 13.5. Those are the digits that would get me to my answer. Because this is 3 sig figs, I would round my final answer just to 3 sig figs, which is 46.9, and then label with the chemical substance as well. So that's a how to use density. It's just another conversion factor that allows you to go from gram to mil. And because you can always go mole to gram, it works out. So there is your helpful instructional video on density.